Hello. It's been raining continuously for 2 days and I've had a miserable time, and I've taken the whole day to do something that should have taken half an hour. I've done a bit of aluminium brazing, I've done a bit of software work, I've got up in the attic and drilled a hole through a wall, I've laid a cable between my study and the garage, and various other things. But what's it all been for? Well, basically just to put a stepper motor on a long-term test. So I'll show you what I've been doing. So here's the stepper motor rudder servo built into an IP68 box, and the circuit which I've made up properly, well I say properly, I made it on Veriboard, and this lid goes over like that and fits on there. And that's more or less finished now. So here we are in my garage, and I've rigged up this long-term test over here. So what we've got is the stepper motor there, clamped between two pieces of wood, which are in turn clamped to this chest of drawers, being driven by an Arduino there. The Arduino reports what it's doing via a serial line which goes up here into the attic. And the stepper motor is coupled to a piece of aluminium by means of a slightly flexible aluminium coupling, and it goes down into this bucket where I have got a pretend rudder, also made of aluminium. And it's in some old motor engine oil. I intend to fill that bucket up with engine oil just as soon as I can get some more. The point of this is to provide some kind of viscous load for the motor that's driving the rudder. Last May, Andrej set up a very interesting long-term test of the JGY 370 motor, and I'm showing a clip here from his video. I've got a link to his video in the description of this video. The interesting thing for me about this setup is that he has a weight on the left-hand side, and I looked at it and I thought, well, that's an asymmetric load. So this weight resists clockwise movement but assists anti-clockwise movement, whereas a real rudder resists movement away from the center and assists movement towards the center. So a real rudder has an asymmetric load, but it's symmetrical about the center, whereas the Andrej test weight is one-sided asymmetric. So that's why I decided to use the bucket with oil. It's not the same as a real rudder, but it's slightly more symmetric load than the weight. This arrangement has been knocked up in a hurry, and I didn't realize that the lack of restraint on the rudder shaft here results in oscillations of the whole mechanism. That doesn't really matter because it's isolated from the stepper motor by this flexible aluminium coupling. But I'm a bit worried that possibly that aluminium coupling will fail due to metal fatigue shortly, but we'll see. I can always replace it if it does. So what's happening here is that the Arduino is generating a random rudder angle somewhere between -60 and +60, where 0 is dead center, and is moving the rudder to that angle and measuring how long it takes and reporting that back up the serial line. And then it waits for a second and then it repeats. So we basically get one movement every second or so. The serial signal comes in through the ceiling down here and onto a serial to USB converter, and then it goes into this old computer of mine that I was going to scrap. so I had actually wiped the disks. So I had to reinstall Windows 7 onto those disks. So now we've got an empty Windows 7 system. So the data from the Arduino in the garage ends up here, where it is spooled to disk and can be analysed later. So what we've got is the 3786, 3787, that's just a sequence number telling me the total number of rudder movements that have been done so far. The next number, 149110, is the total angle through which the rudder has moved in degrees. The next number, 520 thing, is an Arduino timestamp. The next number, 25.0 minus 28, 24, 41, that is the target rudder angle in degrees generated randomly by the Arduino. The next number, 9.36, is the time in milliseconds that it takes the rudder to move through 1 degree. So if you multiply that by 60, it amounts to about just over half a second. So this servo operates at half a second per 60 degrees. The second number beginning with 9, the 9.11, that's just the temperature of the gearbox case in degrees Celsius. And the 1 at the end is a fault bit which comes from the stepper motor driver, and it would be 0 if there was a fault, but at the moment there isn't. So we're spooling all that to disk and can analyse it later. And I started this afternoon, which is Wednesday the 24th of January 2018, so we'll see how long it lasts before something goes wrong. And I bet the first thing that goes wrong is this Windows PC, which has already rebooted itself for no apparent reason once. So the test is started, and I will report back later when anything interesting happens, or if it goes on working for a long time. Thanks for watching.